Welcome back again, 7th graders. Happy to have you here. We are going to continue lesson 4.3 in our chapter 4 unit on proportions and similarity. Today we are going to find rates of change. We know we've been looking at ratios, which are a comparison of two numbers. And we're looking at tables where we have a lot of different comparisons of numbers. And now we're looking at rates of change, so really how things change over time in a table. If you're following along on page 198, also having your vocab out would be a great idea per usual. So the rate of change is the rate that describes how one quantity changes in relation to another. So as you change, just like those pizza examples we've had before, I earn $7 an hour, or I pay $7 per pizza. That's a change. As the pizza amount or the order changes, the cost changes. As the hours you work change, so does your pay. So this is an example of rate of change. So example 1 in your book. In an email, Elisha had 62 entries in her email contact list at the end of 2007. We're going to use the information to the right here to find the rate of change in the number of entries in her email between 2004 and 2007. So she's had this email for a couple years, and there's been a change in the entries of the contact list. So we are going to find the rate of change in between the years that have happened. So we only see here 2004, 2006, but we also have 2007 that we're wondering about. So what we'll do is we're going to have our table here. So we're going to continue on. What is the change here if we have to 2007? In our table above, it's 2006. But we're looking for the change or the difference in the number of entries from 62 to 10. Since she had 10 in 2004 when she started, and now she has 62 in 2007, we're also looking for what was the difference in those number of years. So what's the change in between those 2 years? So we're going to write a rate that compares the change in each quantity. And the change, we're looking for the change in the entries in the change in years. So think of it as, you always know which one's on the top. If you're thinking like, oh, I'm looking for entries per year or miles per hour or amount per unit, you always have to think about what is going to be your top, what's going to be your bottom. As the years change, how do the entries change, for example? So we write the change as a subtraction. So we're looking for what's the difference, knowing subtraction, 62 minus 10. And what's the difference between the year 2007 and 2004? So our contact list, this is what it changed from, so that's what we record here. We do the math on the top and the bottom, so we subtract, and we realize that there were 52 entries difference in the difference of 3 years. So our contacts went up 52 from 2004 to 2007 in that 3 years. So we subtract. Then we do that division and pretty much finding that rate as a unit rate, how much for 1 year. And notice we put approximately, so 52 divided by 3 is approximately 17 entries per year. Remember, this is a rate because as the units, this is a unit rate because it's out of 1. So what we find here is that since the rate is positive, Alicia's email contact list increased, so we know a positive is an increase, or it grew. Her contact list expanded or grew at an average rate of 17 entries per year between 2004 and 2007. Is that maybe exactly what happened? Maybe not, but we're looking for an average or a constant or that rate of change. That rate of change of like, okay, in this amount of time, had it continued at this rate, how much would it be over time? Okay, so no, using our language, increase, grew, and then the unit rate as well. So you want to give this one a try. In your book as well, it's A, checking your progress on heights. So the table shows Ramon's height at ages 8 and 11, and we're looking for the rate of change in height between these ages. So we're looking, are we going to look for year per inch? No, we're probably going to look at inch per year. Okay, so we have to make that, set that up. Let's see if I can do this with writing since I'm on my computer again. We're looking for the change in the height over the change in the amount of years. So height compared to the age in years. So we know we start with, he was 58 inches at age 11. whereas he was only 51 inches at age 8. So we're looking for the difference between age 11 and age 8. Notice how these two line up in the graph. They're also going to line up in your setting up of your ratio here. So here, 51 and 8 line up, and they're also going to line up here. So now we could subtract 58 minus 51 is going to be 7. 11 minus 8 is 3. I'm probably going to want to attach some units here just like we had above, so I keep remembering what I'm talking about. And so this is 7 inches of a change over 3 years of a change. And remember, this is a rate comparison of two numbers with different units. So now to find the actual rate of change, I'm looking for the unit rate. I'm going to express the rate as a unit rate. So I do 7 divided by 3, or really it's dividing both by 3 because you're getting the denominator to 1. And I end up with 2 and 1/3, because 3 goes into 7 2 times with 1 remaining. And that's 2 and 1/3 inches per year that Ramon has been growing. That is the constant, or not the constant, sorry. That is the rate of change at which he's been growing in those 3 years. That's why it's per year. Oops. All right, a little bit more practice for us. We're just going to look at some language that you'll get used to now going forward about the positive and the negative of a rate of change or a line if you're representing it. So a graph of data in example 1 here, so that email contact list, this is a graph representing that same information. The data points are connected by a broken line to show the rate of change. So it changed this much in those 3 years. A positive rate of change is shown by a segment slanting upward, left to right. We read left to right, so we normally look at things, how do they change from the left to the right? So that negative rate of change is shown by a line slanting downward is left to right. So this here would be positive, whereas a line that was going this way would be negative. Little study tip, a broken line graph. In these two line graphs, the lines are broken because there is no data points between. So had there been other information in between, it would be solid. This is important to put in your notes, so I would pause probably right now and just get this written down so that you have this important information. You know that the rate of change is positive if the line slants upward from left to right, and that means that there's an increase over time or over whatever it is you're comparing. A slant downward left to right is a negative or a decrease. And if it's straight, it's a horizontal line, that means there was zero change, zero rate of change, and that means there was no change in that measurement. So I would pause and record that and then move on when you're done. Last little part, we're moving on to page 199 in our book for another example on finding a negative rate of change. This can be a little confusing if you struggle with your integers or are kind of careless with that, so make sure you're on guard for those things. The graph shows the average cost of personal computers for the years of 1997 to 2002. Almost, yes, before you guys were born, probably. Find the rate of change in cost between 1998 and 2000. So this is one where we have a large span of data across, but we're only looking for the information between a certain time. So here to here rather than the whole thing. So we're going to describe how this rate is shown on the graph. So make a table of the data using the coordinates of the points listed on the graph, knowing your x-axis and your y-axis. So your ordered pairs, you know, would be x and then y. So here's a table that's been made. Make a table. So the year, we're in 1998 to 2000. We have that ordered pair. 98, we're at, let me use my pointer here. We're at 1,300 average cost for personal computers, whereas in 2000 we're at 1,000. So we record, the relationship between x and y here. You're going to use this same data to write rate comparing the change in cost. So we're looking at for that rate of change in that time. So change in cost over the change in years, right? Cost per year, not year per cost. So we put those on and we write it like this. So we do our 1,000 minus 1,300, the change, the second to the first, and then 2,000 minus this. Obviously, we want the positive year change. So here that's a negative 300 over 2. What we got for subtracting. So we end up simplifying that as a unit rate for a negative 150 over 1. We have to understand that these numbers have meaning, so we're going to put labels back on them. What this means is that there's a negative $150 per year. Since it's a negative, that means that the cost of the personal computers decreased from 1998 to 2000, and that's shown by a negative, and we know that for sure, and it says this is shown on the graph by a line segment slanting down left to right. And so we could predict that it went down by just looking at that part of the graph. All right, last part. Your turn to check your progress. You can pause and come back. In the graph, find the rate of change between 2002 and 2000. So we're looking from this amount. We're looking from here to here what happened. So in the graph, find the rate of change. So I'm going to grab my pen, and I'm going to do, okay, I'm looking for the amount of money for the personal computers compared to the change in the year. I'm looking for in 2002, I should make that table first where it's, you know, the in 2000. This is my year. Sorry, I know this is hard with the computer pen. And this is the amount, the cost. It was 1,000. Whereas in 2002, it was 855 per personal computer. So that's kind of your table, just so you remember what to line up. So I know I'm going to do 855, my cost, my second cost, minus my first original cost, the change from now to then, and the change in the years. Notice those line up with what they did line up with in the table. And when I work this out, I end up with a negative $145 change in 2 years. And I'm going to make that into a unit rate by dividing, and I end up with a negative $72.50 change per year in the computer change. And then it says, how can I describe the rate of change as shown in the graph? For that, what I would just say is, as the line, I can describe it as the line slanting down from left to right tells me for sure that it is decreasing. A little bit more. Example 3. Just some more of these, making the tables the biggest challenge. So we're going to look at this graph on the right, comparing the change in internet users by the millions from 2003 to 2002. So from here to here. And then the rate of change between 2003 to 2004. So what I see is I can just look at the graph to kind of determine. So it looks like from 2003 to 2004, it's a bit steeper, meaning it goes up quicker than in 2002 to 2003. It's not as steep. So it appears that the rate of change in 2003 is greater than between 2002 and 2003. You can check this by plugging in the values. So I'm going to plug in 2002's change and 2003's change, and that's a change of 3 million, whereas 2003 to 2004 we find a change of 29 million. So what this means is 29 is greater than 3, so the rate of change between 2003 and 2004 is greater than the rate of change between 2002 and 2003. So this is really the same thing. You find the rate of change between different times, and then you're just comparing them together. Give this one a try as well. Use the table to make a graph. So it has a 2-year period. For this one, so you're going to make a graph. When you're making a graph, make sure that you have solid increments. You won't want to start this right here as 1. Since our first unit is 320, our lowest, you want to look at your increments and what you need. And that's why that Jacob's there to show we're starting off at 320, and then the years go by 2s and marking accordingly. So after you make that, what you notice is the rate of change in between 98 and 2000 was the steepest drop, and the graph it's greater than any other 2-year period. This is pretty short, little bigger, short. This is the longest and the steepest change in a 2-year period. Notice this little note on the side here says absolute values when comparing negative rates of change, compare the absolute values. So even though this is positive and this is negative, you're still looking at which was the most, whether it's positive or negative. All right, kind of rushed at the end there, a little bit quick. I know you guys like to make these short and sweet, so rewatch, pause, do whatever you need to do. Look in the book, come with your notes, come with your vocab, come ready to be awesome students like you are.